Hello and welcome to this quick preview of some new tools for COBOL and mainframe developers arriving in the Visual COBOL and Enterprise Developer 7.0 release later this year. As a vendor of COBOL application development and modernization tools, we take great pride in our software, and none more so than in our COBOL development tools themselves. Our integrations into Visual Studio and Eclipse offer COBOL developers a first-rate experience when working with enterprise applications, and they smooth the way for onboarding new recruits into COBOL by providing a familiar and intuitive toolset. More recently, the Visual Studio Code platform has emerged as a popular choice for cross-platform application development for a wide range of programming languages and technologies, and we're delighted to be offering support for COBOL development in VS Code in our next release. Jen Nam, an engineer working on our VS Code integration, is going to take you through a quick demo. Take note of VS Code's inbuilt support for Docker containers, which when combined with Micro Focus COBOL container support, promises to offer a rich development experience for this emerging platform. Here's Jen to take you through the details.
Thanks, Scott. And now for a quick introduction. My name's Jen. I'm a developer on the Visual Studio integration team. On a day-to-day basis, I work on adding COBOL support to Visual Studio. And for this release, we've extended this to include Visual Studio Code. Visual Studio Code is a lightweight text editor similar to tools such as Notepad++, whilst full-blown Visual Studio is a more traditional IDE that integrates deeper with your source code. And now I'd like to just run through a quick demo of what we've added to VS Code to support working with COBOL and some of the benefits this brings. In the demo, I will show you how you can leverage the remote development capabilities in VS Code to simplify targeting different platforms. Specifically, I will show how to develop and debug your COBOL code that will be run inside a Linux Docker container from a Windows host. This is my Windows machine with Docker installed. You'll notice that I've set up a Linux image containing our VC Dev Hub product in advance. Note that VS Code can work with a number of our COBOL products, including Visual COBOL, Enterprise Developer, and their respective build tools. The VS Code extension also supports both Windows and Linux. Now let's take a look at VS Code. In here you see that I've already opened up a folder containing my COBOL sources. So here is a COBOL program, a copybook, and a custom build script. To set up remote development, you simply need to create a dev-container.json file, specify the image you want to use, and tell it to use our COBOL extension. Once you have this set up, you click on the bottom left and click Reopen in Container. At this point, VS Code will then launch a new container containing your COBOL development environment and make your source code available through it. Once it's finished loading, we can see our sources on the left, and on the bottom here, it indicates that we are now developing inside a container. Once our folder has been loaded into the container and remote development started, we should now have access to our Linux versions of the compiler and COBOL runtime. If we take a quick look under the extensions sidebar, we will see that the Micro Focus COBOL extension has been installed, giving us access to our COBOL features. So now if we open up our program, you'll see that everything has been colorized as you would expect. If you use a particular dialect or a particular source format, this can be changed down here, and the colorization will update as needed. By having a suitable task.json file configured, it is possible to trigger builds directly within VS Code and have the errors show up inside the editor. To trigger the build, we simply go into Terminal, Run Build Task, and we select our task. The output is then shown under the Terminal tab, and we can see that we have a couple of build errors. If we double click on the build error, it will navigate us to the correct location in the file and also put a squiggle under the error. Here we can see that we've forgotten to close the quote. And if we just take a look at the other one, we're using the wrong variable here. This should be get OS block. And with any luck, if we build again, this should build cleanly and produce no errors. Excellent. Next, I'd like to quickly show off how you can debug your COBOL code now. The first thing you need to do is set up a suitable launch.json, which simply tells VS Code what executable to launch and to use our COBOL debugger. As always, let's set a breakpoint in our code, and then to actually start the run, you go under Run, Start Debugging. Once our COBOL code has launched, we will halt on the line where our breakpoint is, and you should have access to everything that you would typically expect when debugging. So we can step through our code, we can step into the copybook, we can step out of the copybook, and so on. If you notice on the left, we have a debug perspective. So we have a locals window which shows all the variables that are close by the statement. We have a watch window for showing any queries. So if I type get OS block, this will return the value of get OS block for us. And we also have a call stack and a breakpoints window. You can also hover over the various variables in the editor itself to get the values. If you actually look at the code itself, we make a call to get the OS version, and then we have an evaluate statement to switch on it. So we step through here. You'll see that we are in fact debugging under Linux, and if we look in the call stack, you'll also notice that we have Linux style paths. This is just a quick proof to show that we are in fact debugging on the remote end and not locally on Windows. And so that largely concludes the demo of the COBOL support we've added to VS Code in this release. To summarize, we've shown how it is possible to compile, edit, and debug your COBOL code on a remote machine as if everything was being done locally. In this case, we demonstrated using a Linux Docker container, but you can achieve the same thing using SSH with a real remote machine. And naturally, VS Code works great when used locally as well, without the remote bits. Personally, I use it a lot to make quick edits as it is very lightweight and flexible as a text editor. Being able to build inside VS Code from a custom build script also allows people to get started with minimal overhead. And now I'd like to just bring it back to Scott. Thanks.
Thank you, Jen. Great job. We hope to have VS Code available for you to try soon. And if you'd like to join the beta, please get in touch with me directly. Thanks for watching. I hope you're enjoying Universe, but please take the time to check out our other AMC demos in the demo booth while you're here. Bye for now.